Now that we've talked about arithmetic sequences, we need to talk about arithmetic series. An arithmetic series deals with an arithmetic sequence. What an arithmetic series is, it's the sum of the terms. So if I wanted to add up the sums of an arithmetic series, I wanted to add up the terms of term 3 to term 8, I can do that, and that would be considered an arithmetic series. We all know that sum is addition. So let's say that my sequence is 1, 3, 5, 7, 9. So if that's my sequence, my series is then 1 plus 3 plus 5 plus 7 plus 9, which equals 25. Okay. So our sequence is 1, 3, 5, 7, 9. Our series would then be 1 plus 3 plus 5 plus 7 plus 9 equals 25. Now, there is a special formula that you can use in order to figure out the sum. So that formula, so this is my sum, equals n divided by 2, parenthesis, a1 plus an. Okay, so what exactly does that mean? What that means, this is my sum. N represents the term number. A1 we know is our first term. And AN is our last term in our sequence. Now, something to note. Based on an arithmetic sequence, we know that AN has to equal A1 plus N minus 1D. This will come in handy, because sometimes you won't know what the last term in the sequence is. Instead, you might have to plug in that last formula there for how to figure out your arithmetic sequence. So let's just work with the first one and then we'll get into the second one. So for instance, if I am looking for the sum, which in Greek notation, that is my summation. You'll see that throughout, so I just want to kind of give you guys a heads up of what it is. The sum of the first 10 odd integers. So we know our formula, our sum, equals n divided by 2, a1 plus an. All right, so what is our n? Our n is the first 10 odd integers. So we know then that n is 10. A1, well, what's our first odd integer? would be 1. Looking at this, my next odd integer is going to be what? We know that this is going to be 19. So I have 5 times 20, which gives me 100. Some of you might find that it's actually easier to just list out the first 10 odd integers and then just add them. That's okay. I'm just telling you this is a formula in case we get larger numbers. It may be easier to use that. Now let's talk about when they don't necessarily give us enough information. And we're going to have to use that an equals a1 plus n minus 1 times d. So for instance, or if it's something that you aren't exactly sure of what the term would be. So let's say that it's the first 30 odd integers. Okay, so I might not want to list out 30 odd integers. This is where plugging in that a1 plus n minus 1 times d is going to help out. Okay, so I've got my summation. We know this is 30 equals 30 divided by 2 times, well, what's a1? a1 is 1 plus. So we need that an term. Well, I'm going to represent that with the a1 plus n minus 1 times d. Okay, so I'm going to plug in the information I know based on that. Based on that information, a1 doesn't change, it's still 1. Plus, well, how many terms am I looking for? 30. What's the difference? As I go from 1 to 3, what am I doing? I'm adding 2. So my common difference is 2. So now I have an idea then of what the an is going to be, but I might not necessarily know right away when I first begin this. So now I'm just going to go ahead and simplify this. So I have 1 plus, and then I have 1 plus, I've got 29 times 2, which is going to give me 58. So I've got 15 times 60. Well, I can do a little math over here off to the side. 15 times 6. Add the 0 is going to be 900. So I know then that the sum of the first 30 odd integers is going to be 900. Okay, so let's talk about the sigma notation and the summation notation here. Let's say I'm going to get a little bit fancier here. This n equals 2, that represents my first term. You're going to then have a number on top. This represents the last value of n. And then they're going to give you some type of formula. Okay, and that's where you're going to find your sum. So let's just say it's 2n plus 3. So what does this mean? This means that my first term is going to be 2 times, well, what's the first term value? First term value is 2 plus 3. So I know that's going to equal 7. So that's my first term. Then I have to keep going until I get to the 7, so the last value. So that's telling me how many terms I'm going to have. That's the value I'm going to be plugging in. And I'm actually missing one. So notice here when I'm going through this, what gets plugged into the parentheses just keeps increasing. It goes from 2 to 7, which relates back to these numbers over here. It relates to those numbers there. So I have 2 times 2 plus 3, 2 times 3 plus 3, 2 times 4 plus 3, 2 times 5, until I get to that top one. Okay, so then after I figure out all of those values, I just add them all together because it's a sum based on my sigma. So I've got 2 times 3 gives me 6, plus 3 gives me 9. 2 times 4 gives me 8, plus 3 gives me 11. 2 times 5 gives me 10, plus 3 gives me 13. Notice, I've picked up on the pattern here and can just plug those numbers in. So we actually haven't gotten to a question, which is fine. I just want you guys to make sure that you have taken the notes.